Here we'll be looking at the structure and bonding and the properties and uses of diamond. So diamond is a giant covalent structure where each carbon atom is strongly covalently bonded to four other carbon atoms. There are no free electrons and the carbon atoms form a regular tetrahedral network structure. The properties and uses. So due to the strong covalent bond, this makes diamond very hard, which makes it useful as a tips in cutting tools. Diamond also has a very high melting point, which is around 4000 degrees Celsius. But however, as there are no free electrons, it cannot conduct electricity. The structure and bonding of graphite. So graphite is also a giant covalent structure where each carbon atom forms three covalent bonds with other carbon atoms. The carbon atoms form layers of hexagonal rings and there are no covalent bonds between the layers. There is a delocalized electron from each atom. The properties and uses. As there are delocalized electrons just like metals, graphite can conduct electricity, so they can be used in electrodes in batteries and for electrolysis. Because there are no covalent bonds between the layers, the forces are very weak and therefore the layers can slide over each other, so they are soft and slippery, meaning they can be used as lubricants. Graphene, fullerenes, and carbon nanotubes. Graphene is a single layer of graphite, and because of the strong covalent bonds, they are strong and have high melting points. This means that they can be used in electronics and for making composites. Fullerenes are molecules of carbon atoms that have hollow shapes, and their structures are based on hexagonal rings of carbon atoms joined by covalent bonds. These fullerenes include rings with 5 or 7 carbon atoms, and they are used as lubricants to deliver drugs in the body and catalysts. Carbon nanotubes are like layers of graphene, but they are rolled into cylinders and they have a high length to diameter ratios. They also have high tensile strength, meaning they are hard to stretch, and they can also conduct electricity as there are delocalized electrons. These properties make nanotubes useful for electronics and nanotechnology, as well as to reinforce other materials.